Good morning, everyone, and hello. About a year ago, I was on the stage delivering a keynote, in fact, right after Vicky, and I thought about, what we've accomplished in the last year, and it got me thinking about everything that we, Intel, as well as all of you, what we've been doing together in this whole NFV and SDN journey. We've been working together as an industry in moving to NFV and SDN for the last, I would say, 6 to 7 years. And like Vicky pointed out, there's no debate about do we need to do NFV and SDN. I think the industry has kind of, arrived at that decision. They've kind of moved on. They're in the process of implementing NFV and SDN. But I don't believe that journey is complete yet. There's still a lot of the modernization of the network for a truly intelligent, scalable, agile, and flexible network that we still need to do to result in the type of digital transformation that you heard about earlier from Vicky. At the same time, while we are doing this, we are all, as an industry, dealing with not only the opportunity of edge computing, but also the challenges that it represents and how we integrate edge computing, how we move data-centric cloud computing workloads from the data center all the way to the edge. And all of this while getting ready for the promise of 5G. How do we get our entire network and our entire infrastructure ready for 5G and deliver on the promise of digital transformation and drive business value to all the vertical industries and businesses out there? When I think about 5G, I think about ultra-reliable low latency. I think about enhanced mobile bandwidth. I think about massive machine-to-machine communication. But at the same time, I also think of the mobile core infrastructure. I truly believe that that is one of the most critical and most important pieces in order to deliver 5G. And our industry has been working on modernizing the mobile core infrastructure. In fact, several operators are currently deploying 5G in a non-standalone mode, and it serves as a foundation for 5G, and they're doing this on Intel architecture. The operational benefits of 5G in the NSA mode, which gives them the portability and the scalability across the entire network infrastructure, is extremely important for them. At the same time, this common architecture, the software-defined architecture, the cloud-native or virtualized architecture across the network, from the core of the network to the edge, is what truly gives this flexibility and scalability. Intel has been working with some of our partners in order to develop and improve the mobile core infrastructure solutions. 3 of our partners, Affirmed, Metaswitch, and Ericsson, publicly shared their core network capability on Intel technologies with performance ranging from 168 gigabits per second to 193 gigabits per second, and also to about 500 gigabits per second. Additionally, we've been collaborating with Vodafone Idea, who is servicing about 4.2 terabits per second across numerous locations in India. And they're growing these locations at a rapid pace. And we're collaborating with them to develop what we call the network as a platform in order to deliver hundreds of new types of services. For the last several years, we've been working with the industry, with the communication service providers, with various software vendors to understand, what are the true needs of the network and how can we design products, how can we take a customer-first approach to design our products and solutions. A few months ago, we launched the 2nd generation Xeon Scalable processor, which was designed for the most demanding workloads from the cloud to the edge. We took the learnings that we have from our customers and we customized this Xeon scalable processor further to create what we call the NSKU, so it's customized for networking. And what this is, the NSKU, when used by the operators in the network, is resulting in better throughput. It's resulting in an ability to meet service level agreements in a better way and optimize TCO. And we have better performance per watt per dollar than our first generation processor. Now, our CPUs are not the only thing that we're designing for the network. We're also looking at the Intel FPGA programmable acceleration card N3000. So this card is one of a kind. It's a game changer. And it is capable of handling bandwidth up to 100 gigabits per second. We have several industry partners who are partnering with us to commercialize this. And this allows the industry to customize their solutions with acceleration from the radio access network all the way to the core of the network. And you can see some of the partners demonstrating this card in the show floor at this show. When we think about edge computing, I think about it from everywhere from the next generation central office to the base stations or the radio access, which kind of forms the network edge, but it's also on the on-premise edge or the enterprise edge. And this is crucial from delivering various levels of service agreements through latency, throughput, different forms of connectivity, and others. And Intel has been working with various partners at different edge locations to determine what is the best type of platform or solution to deliver the best return to our customers. I'll walk through a few examples of some of the solutions we're putting together with the ecosystem and with our industry partners. I'll start with the radio access network first. Here we have a pretty wide portfolio of solutions for the RAN. Not only our Atom and Xeon processors, but we also have our FPGAs as well as custom ASIC solutions that are utilized in our base stations. And we're partnering with various industry leaders in not only the custom ASIC solutions for base stations, but also virtualized RAN solutions. A few months ago, we shared details about our 10 nanometer SoC, codenamed Snow Ridge, and this is designed for extremely data-intensive workloads across the 5G access networks, taking Intel architecture into the base station. From a next-generation central office perspective, this is one of the key areas where we're partnering very closely with our service providers. In fact, re-architected, a central office is like a fiber-rich edge mini data center. And it's capable of handling not only fixed and mobile traffic across residential enterprises as well as the mobile traffic. And it's very ideal for Xeon scalable processors. It typically services about 35,000 subscribers. And one example of one of the cable providers we were working with, they replaced about 10 of their racks with one rack for the head-end facility and about a half rack for the R5. So they realized tremendous savings just from the OpEx, from reduced power consumption and HVAC cooling costs. And they're looking to service the same number of subscribers with the same quality of services. In fact, I'd like to welcome Dr. Diego Lopez from Telefonica. He heads the technology exploration and standards in Telefonica, and I'd like to welcome him to talk more about the collaboration between Intel and Telefonica in re-architecting the network as well as the central office.
Thank you, Renu. Good morning, everybody. Well, basically, I will try to be very brief against my normal behavior, and it's about just to introduce you a little bit how the journey. Can you? Because
Sure.
I don't. Thank you. So. How we started, it's a journey that started sort of 10 years ago with the direct help from Intel, precisely when we wanted to test our first virtualization trials and to demonstrate that the technology was feasible. And our idea is always something that we have insisted very much, and that is about bringing the results from IT in virtualization in cloud, etc., not making a direct translation and making that the network will run on a cloud, but the fact that we wanted to adapt what the findings of IT to the network environment with, trying to address things like the relevance of topology in networking, or the relevance of the conservation of data in networking, the relevance of isolation in networking, in bringing something that, if you see in the diagram there, is how we have evolved from, or for sure, the traditional network, so to say, we have evolved into something that has become more cloud-like, and hopefully in the short future will evolve in something that would cover the whole network. That, let me insist, is one of the bases, is precisely how it deals with topology and with the fine-grained topology that is the main characteristic of the network. This is the path, the evolutionary path we have set, and if you see, there is not only that we are making changes in virtualization, we are relying as well in making a full evolution of all our service stack, from the access technologies, radio, core, optical core, etc., and the IT infrastructure as well, into something that is basically an open digital environment in which we can run any function on a highly distributed, consistently orchestrated set of cloud resources. And for doing so, well, there is a set of things that we believe are required, starting from a simple network, the possibility of applying automation. What is very important is designs in terms of standards and open source, SDM for sure, and something that we rely very much on you in Intel is precisely on having cloud mechanisms that are not only cloud capable, but are network aware as well, which is something that is essential. And that's all. Thank you.
Thank you so much. We look forward to continued collaboration. So from the network edge, I want to switch to the on-premise edge, or the on-premise enterprise edge, and where we are seeing, tremendous innovation, where we're seeing a lot of the first edge deployments happening. In fact, in our show floor today, you will see, a demo which takes the UCPE platform and builds on top of it. SD-WAN is becoming a pretty, accepted way for WAN connectivity in the enterprises, and a lot of the service providers want to build on top of the UCPE platforms. So they're looking at adding not only analytics, but they're looking at adding things like secure device onboarding. They're looking at adding other types of services by having, a big cloud developer ecosystem as well. So the demo in our show floor has a Dell VEP 4600 platform that's based on the Intel Xeon processors. It adds like an ADVA ensemble connector that does service chaining with a Nokia Nuage virtual SD-WAN and a Fortinet virtual firewall. It also has the Intel Secure Device Onboarding Kit, which onboards IoT devices in a secure and trusted manner onto the platform. And it also includes OpenVINO, which is a toolkit for visual inferencing and neural optimization. So it's used for a lot of analytics applications on top of all of this is on top of the UCPE platform. So if you get a chance, please go and check it out in the show floor. The other type of on-premise innovation that I want to share today is When we looked at, you heard Vicky say earlier about how integration is still a challenge. And so we were coming up with ways to alleviate some of the integration challenges for the industry, and we kind of designed this common edge reference architecture. What it does is it takes some of the hardware and software ingredients and integrates that into a single unified platform that can be used across numerous vertical use cases: industrial, retail, smart city or transportation, or healthcare. Two of our partners, Foxconn and QNAP, are actually commercializing this common edge reference architecture. So you will see their solution in our show floor booth at this show. It integrates not only the Xeon processor from a hardware perspective, but also some of our accelerators like FPGA and the Movidius chip. And from a software perspective, it integrates not only OpenVINO for analytics, but also one of our software toolkits called Open Network Edge Services Software, or OpenNES. We launched it at MWC Barcelona, and we have it available as an open source toolkit. And both Foxconn and QNAP are integrating OpenNES and OpenVINO on top of their platforms, and they're commercializing the Converged Edge reference architecture. So please take a look at it at our show floor as well. I want to share this video of key partners as well.
Edge computing. When you're building an ecosystem like this, you usually need a strong player in the sort of the center of the ecosystem. Traditionally, Intel has played this very strong role in creating the ecosystems.
QNet has been developing the QCP solution, including AI inference at the edge and many more. At the R&D stage, the OpenNES reference architecture serves as a guidance, and some of its microservices are implemented.
We have been closely collaborating with Intel on the 4G, 5G, multi-access edge computing.
We have been working together with Intel on OpenNES in a video analytics project to create a blueprint for how this could work.
OpenNES not only provide lightweight traffic steering capability for Sigma platform, it also greatly enriched Sigma ecosystem by introducing Intel ecosystem to China Mobile.
We will continue our partnership with Intel and adopt Intel Converged access reference architecture to develop our product.
The most likely way to create a standard fairly fast is that a few operators go together and start and create something. Telstra, we are very inclined to be among the first working with companies like Intel to create these standards.
So in addition to the Converged Edge reference architecture, we have been working on this program called Intel Select Solutions. What it does is it takes some of these hardware and software ingredients and pre-configures it, pre-verifies it, and makes it, helps to alleviate some of the foundational integration problems that our OEM partners would have. Over the last couple of years, we've released various Intel Select configurations for NFVI, for CDN, as well as for UCPE. A few weeks ago, we announced the Intel Select for NFVI forwarding platform. At our show, you will see a version of the NFVI forwarding platform that's implemented by WWT. It's based on Advantek's Intel Select solution for forwarding, NFVI forwarding platform, and it uses the NetElastic's virtual BNG. So we do have a new Intel Select as well that our partners are implementing and commercializing and showcasing at this show. So again, please check that out. And then last but not least, Intel, we're a technology provider, and we can't do either NFV and SDN by ourselves, or edge computing by ourselves, or the move to 5G by ourselves. We definitely need to work with the vast ecosystem out there, with all of you, and partner with you to not only bring together key standards, but also help alleviate some of the challenges we have as an industry, and then support each other in driving solutions into deployment so that all of us can benefit from the digital transformation that edge and 5G, as well as a robust, intelligent network can promise. So thank you all for your time. And with that, I'll call our organizers back.
All right. Thank you, Renu. Excellent. Appreciate that.